We have defined a class called sorting, and we are going to define the selection sort as a static method inside this class. Since the method is static, so we can use this method by writing the name of the class followed by the name of the method, and we supply the array that we want to sort as an input parameter. Now we need to implement the method getIndex of smallest so that we can test our program for sorting an array of integers. So we will define this method getIndex of smallest as a private static method. Why? Because we want to use it only internally inside the class. We don't want this method to be exposed outside. Why? Because it's a helping method that is used for the selection sort. So how to define it? We will write private static, and it's going to retain an index, so it retains an integer, and the name will be getIndex of smallest. I will simply copy the name of the method and paste it. It will have an input parameter as an index, so it will be integer, and we will call it start index, as well as the second parameter will be an array of integer, so it will be an integer array. We will call it A. To find the index of the smallest integer, we need to define a variable that will hold the smallest integer. And remember how to find the minimum element in the array. We assume that the first element is the minimum. So we will define an integer, we will call it minimum, and it will hold the first element in the array. So A start index, because this is the first element supplied as an input parameter. Then we write a for loop that will look for all subsequent numbers after start index. Any element that is smaller than the minimum will replace the minimum. So we write for integer index is equal to start index plus 1, because we need to look for the elements that is after start index. And then index is less than a dot length index plus plus. And any element is smaller than minimum, it will replace minimum. So we write here if statement. We say if a at index, if it is less than minimum, then we replace minimum by a index. So we write minimum is equal to a index, which is the minimum. But in fact, we are not looking for the minimum number. We are looking for the index that has the minimum number. So therefore, we are going to define a tracking variable, and we are going to call it integer index of minimum. So once we find the minimum, we have to track where is this minimum. At the beginning, we will assume it is at the start index, because we assume the minimum is the first element in the array. Now in every iteration, whenever we change the value of minimum, then we have to change the index of the minimum. So here we say index of minimum is in fact equal to index. After we go out from the loop, I think we are missing a bracket here. After we return back from the loop, then we have to return the index where we found the minimum. And this is going to be index of minimum as a return value. Now the selection sort is implemented in a method inside a class. Now we need to write a program to test the algorithm on some arrays. Let us write the program. We go to File, New, and now here is our program, public class, and we are going to call it array sorters. And inside we will write the main method, public static main args, and as you notice that the argument for the main method is in fact an array of strings. Notice here that the argument to the method string is an array of strings. So inside we are going to create an array, and we are going to call the selection sort to sort this array. So we will define an array, and we are going to call it array1, and we are going to fill it with random numbers using the method that we have created before that generates random list. So it was called random list, and we specify the size, let's say for 100 integers, that the generated numbers should be of width, let's say 6 digits. We have already implemented this method before. We are going simply to paste it in our code, and we are going to make a slight modification for the program. Let us format it first. Now it is formatted. As you recall, that the method will generate random numbers. The number of these numbers is S, and the number of digits for the generated numbers is of size D. Now we would like to make a small modification to this method. We wanted also to generate negative numbers, not only positive numbers, also negative numbers. So inside the for loop, after the number is generated and saved into the array, we are going also to make random selection on whether the number should be positive or negative. So we will do the following. We will generate random numbers between 0 and 1, either 0 or 1. And how to do this? We will implement it by using the method math.random. Since we need two values, 0 and 1, we are going to multiply it by math.random. And here we will see what is the result. If it is equal 1, then we will change the value that was saved inside less into negative number. So simply we will take the element and we will multiply it by -1. So this expression will generate random numbers either 0 or 1. If it is 1, then we will change the generated number that was saved into the index variable list I into a negative number. So let us save the program and compile it before we proceed. So we will save it. And we are going to save it inside arrays project. It is called array sorter, the class. And we will now check for errors. So there is an error, main. Yes, we forgot to put void. So public static void, the return value for main. Let us try again and check. So now the program is free of errors. Now is the time to check the selection sort that we have created in the sorting class. So the array now is generated. Now how to sort it using the selection sort? We know that we have defined the method for selection sort inside a class called sorting. Sorting, and the name of the method is selection sort, and we defined it as a static method. So simply we say sorting, which is the name of the class, dot selection sort, and we give array1 as an input parameter to the method. After we return back from this method, we want to print the array and make sure that all the elements inside the array were sorted in ascending order. Remember that inside the selection sort, we did not give an option whether to sort in ascending order or descending order. We could have an option in here, true or false, as a Boolean variable. If it is a true, then we can make the sorting in ascending order, and if it is false, we can make it descending order. Let us finish from this implementation, and then we will show you how to make this a slight change to the method selection sort. So after we return back from the method, we want to make sure that the elements of the array are sorted. So simply we write a for loop for integer I equal to 0, I less than array 1.length, I plus a plus, and we are going to print each 10 numbers on a line. So here we will print system dot out dot print, and we are going to print the element array 1I followed by a tab, and if I plus 1 modulus 10 equal 0, then we are going to print a new line. So let us run the program and see the result. We compile. We have a problem with the index here. It's supposed to be I. And now we compile again, or let's run it directly. So let us see the result. The output shows that all negative numbers are put in the beginning and all positive numbers are put later. And look at the end, here we have the number 998461, the one that's before it 995, the one before it 962. It looks like that the array has been sorted correctly. Now if we would like to increase the size of the array, we would like to see how the algorithm will perform. Let's say for example here we would like to increase it to 100. And then we will run it and see how fast it's going to print the array. And now it is sorting. And maybe we should proceed before calling the selection sort a message by saying system.out println, and here we say sorting and we put dots. So that means we are just now calling the method selection sort, and then here we would like to print a message after it is done. We will say system.out.println sorting is complete. And we would like to see the time between printing sorting and sorting is complete. So here maybe we can say sorting has started, and here we say that sorting is complete. So let us run the program for, let's say, 10,000 number of integers. We run it now. Maybe it is printing fast, so maybe we should remove printing the elements because the size of the array is very large. So we will remove printing the array, and now let us run it again, and now the message will be printed here. See, it says very fast sorting has a starting and sorting is complete. So as you see that the algorithm performs very fast. Let us increase the number of zeros. So now we have 100,000. Now let us run it. So now it says sorting has started, and as you see that it took a moment of time to give the result that sorting has completed. Let us increase one more zero here. So now we have 1 million. And let us see how fast it's going to be for sorting. So now sorting has started. Now it is inside the method. It is trying to sort all the elements in the array. Let us see how much time it's going to take to print the result. It seems that it has took a long time, so I'm going to end it. So for 1 million number of integers, it is not practical to use it. Let us just increase, instead of 1 million, we will say 500,000, or let's say 200,000. And let's run it. It takes a time now for sorting. Now we are waiting. Sorting has started. Now the result is coming back. So when we increase it, let's say to 300,000 and run it again, so maybe we can count by seconds by ourselves. Sorting has started. Maybe it takes around 5 to 6 or 7 seconds. So as you notice that the performance of the algorithm degrades if the size of the array increases. However, if we try to use the sorting algorithm that is implemented in the Java class library, as we mentioned before, we already have a sorting algorithm that is implemented in one of the Java classes in the package java.util. Let us use this sorting algorithm and see how it performs. So here we will say import java.util.arrays. So this is the name of the class library that is provided by Java system, and it is inside java.util package. Now how to use it on our array? We simply supply array1 as an input parameter to arrays.sort. So simply here, after we generate the array, we will say that arrays.sort, and we will provide the array as an input parameter. But to compare the performance between the selection sort that we have implemented and the sort that is available in Java class library, we need to have the same array as an input parameter to both of these algorithms. So we need to make a copy of array1 and save it into another array. We are going to call it array2. So when we call the selection sort, we will give it array1, and when we call the sorting algorithm that is available in Java library, we are going to give it array2, and then we will measure how much time for both of them it takes for the same array. So here we define the other array, and we are going to call it array2, and we need to make a copy from array1. Remember that before we implemented a method that was responsible for copying between two arrays. If the input parameter was the source, then it will give us the new array as a destination or as a return value. So it was called copy, and we supplied array1 as an input parameter. And this method will retain a new array that has exactly the same elements of array1. We need to implement this method in our program. We have already implemented this method before, so simply we are going to copy it in our program. So here we are going to paste it, and this is the method that is responsible for copying an input parameter array and retain it as a retain value as an entire array. Let us check that it does not have any errors. There is an error, and here I think we forget to put a new because we have to create a new array. Now we compile it. So it is working fine. Compile it again. So it is working correctly. So let us go back to our code. And now first we are going to call the sorting algorithm that is provided by Java class library. And here we are going to say system.out.println, and we are going to say that Java sorting algorithm, and we are going to put dots to indicate how much time it's taking. And then we are going to call arrays.sort array1. And then after that, another message will be printed by saying sorting, let's say with selection sort. Sorting with selection sort has started, and then we compare how much time it takes between the two messages. To estimate the running time of each of these sorting algorithms, let us say a millisecond or seconds, we are going to use a method that is available as a Java class library to give us the current time in milliseconds. This method is in system class library that is defined in java.util package. We will use this method to give us the time in milliseconds before calling any of these two algorithms, and also we are going to use it to give us the time in milliseconds after coming back from the call. Then we will take the difference between these two times to represent the estimate time the algorithm has spent for sorting. The method is called current time millis that gives us the current time in milliseconds. It's available in the system class library that's available in java.util package. So therefore we can bring all class definitions in this package by writing dot and a star, and it will bring all class definitions available in this package, including the scanner, including arrays, and etc. So let us now call the method before we call the sorting algorithm. So here we write system dot current time millis with empty brackets. This will give us the current time in milliseconds, and we are going to save it in a variable. We are going to call it start time. So here we will record the start time of the sorting algorithm that is available in the Java class library. When you read the documentation of this method, it returns a long integer. So therefore we are going to define this variable as long integer. After we come back, we need to define another variable and read the current time and save it into this variable after we come back from the call. So we are going to call this variable as end time. So before we call the sorting algorithm, we record the current time, and after sorting the array and we return back from the sorting algorithm, we are going to record the time again. We call it end time. Now we take the difference, and the difference will give us the estimate running time of the algorithm. We are going to print this time in milliseconds and seconds. So here we are going to say system.out.println, and we will say that this algorithm, it took this amount of milliseconds, and we are going to print just only the difference, which is end time minus start time, and the answer will be in milliseconds. Now to print the running time in seconds, we have to divide the difference by 1000 because 1 second is equal to 1000 milliseconds. So we say OR, and here we print the end time minus start time, and we divide by 1000 to give us the time in seconds. We need to print millisecond for the first time that is displayed on the screen, and we are going to write ms, which is short for millisecond. And we need to print second for the second time. So this number represents the running time in seconds. So we will follow it by the letter S, which is short for seconds. Now to estimate the running time for the selection sort, we will do the same. We will record the start time before we call the algorithm, and then we will record the time after we return back from the algorithm. So we will copy this line, and before we call the algorithm, we will paste it, and since we have defined the variable, there is no need to redefine it. We are going just to reuse it, and after we return back, we are going to record the current time, and at the same time we are going to print the difference between the end time and start time. So we will paste these lines, and again we have defined this variable before, so there is no need to redefine it, and so the program is complete and ready to run. So we will save it and compile it to make sure that it does not have any errors. So there is an error. Let us see what is this error to correct it. We have a spelling mistake here, and we forgot to write T, and also here we forgot to write T. Let us compile it again. And now the program is free of errors. After looking at the code closely, I have found a problem. Notice that array1 is given as an input parameter to the Java sorting algorithm, and when we return back, it's going to be sorted, and we are given the same array to the selection sort. So that means array1 is already sorted, given to the selection sort. So we cannot compare the running time between these two algorithms because we are given two different arrays. So therefore, we have to give the Java sorting algorithm array1, and we have to give the selection sort array2 because we already have made two copies. Both of them should have the same number of elements. There is also another mistake. Notice that before calling the selection sort, we are recording the current time into the variable end time, and after returning back from the selection sort, we are also recording the current time into end time. So therefore, the difference will not be exactly what we want. Here we made a mistake in line 16, and instead of end time, we wanted to have the start time. So we record the start time before calling the algorithm, and then we record the end time, and then we take the difference and print it on the screen. Now let us compile the program and check that it does not have any errors. So now it does not have any errors, so let us start our experiment. Let us run our program on our first experiment. We would like to test the performance of the two sorting algorithms on an array of size 500,000 integers. So we will remove 10, so instead of 5 million, we would like to test them on 500,000 integers. Let us run the program. So the Java sorting algorithm, it took 0.206 seconds. And now for the selection sort, it is still sorting the array, and we are waiting for its performance. As you see that the selection sort has sorted the array after 34 seconds. By comparing the two algorithms, notice that the Java sorting algorithm outperforms the selection sort. Let us repeat the same experiment, but this time we would like to test them on 1 million integers. So let us run it and see how they perform. Look for the Java sorting algorithm. It took only 0.3 seconds to sort the array. However, the selection sort is still sorting the array. So let us wait for the selection sort to complete and see how much time it takes for sorting the array. Finally, the selection sort has finished sorting the array, but it took around 146 seconds, which is almost 2.4 minutes. By comparing the performance of the two algorithms, the selection sort is way behind the Java sorting algorithm. 2.4 minutes for sorting only 1 million integers is considered slow compared to 0.3 seconds. Therefore, the selection sort is not suitable for large size of arrays, because usually programs sort arrays of sizes in millions, and therefore must be fast enough to give results in a reasonable amount of time.